Hi there, this is the Unit 3 review, and as always I am the amazing Mr. Jansen. So away we go. If we look at this first one, we're just using our rules of exponents. And with the rules of exponents, the numbers out front, we do the same thing we've always done with here. So since we're multiplying, I take the 2 times the 9, and that gives me an 18. Now, rules of exponents are always one step back, so when I multiply, I'm actually going to add the exponents. So that's going to give me an a to the 7th. That's going to give me a b to the 6th. And it's going to give me a c to the 3rd. I add those exponents. That's it. So I multiply the numbers out front, I add the exponents. All right? In number 2, I've got a couple things happening inside the parentheses, and I could go ahead and do this division, and when I do that, I divide the numbers out front, and I subtract the exponents. But then I realize that this thing is being raised to the 0 power, and remember, with rules of exponents, anything to the 0 power actually equals 1. So this whole thing's actually just going to equal 1, and that's it. All right, and that's just assuming that I don't have zeros for some of my variables here. Okay. Number 3, again, I've got some division happening here. I'm raising it all to the 5th power. The easiest thing to do is follow order of operations. So I'm going to start inside the parentheses. All right, I'm going to start inside the parentheses with the division because following order of operations just makes things a little bit easier. So inside, when I divide, I do 18 divided by a -9, which is a -2. When I divide, I subtract the exponents. So here, just be very careful with your signs. That's a 4 and a -2. When I subtract 4 minus a -2, it gives me a +6. So that's x to the 6th. Again, I subtract the exponents as a y to the 4th, and then a z to the 4th as well. Okay. So now from here, I'm going to raise it all to the 5th power. Let me drop that 5 down here. So I'm raising it all to the 5th power. And when I raise -2 to the 5th power, that's the same way it's always been because it's a number. So -2 to the 5th power is a -32. I multiply the exponents. That's my rule for exponents. That's an x to the 30th, a y to the 20th, and a z to the 20th. And that's it. All right. So I divide the numbers out front. I subtract the exponents. Then when I raise it to a power, I raise the numbers out front to that power, and I multiply the exponents. All right. In this next one, I'm going to be simplifying the radicals, and I want to leave them in radical form when necessary. So when I look at something like this guy, I've got a negative on the outside, and then I have the square root of 81. Well, the square root of 81 is a 9, and then I just tack on that negative sign that was out front, and that's it. All right. Number 5, I kind of do the same thing. I take the square root of each of these separately, so I do the square root of 9, which gives me a 3. Over, I do the square root of 16, which gives me a 4, and then I just slap that plus or minus sign back onto this thing, and that's it. All right. With something like number 6, because I can't just go ahead and take the square root of 48, I have to look for perfect squares that divide evenly into 48, and I want to try and find the largest perfect squares that divide evenly in here. So 48 I'm going to break down into 16 times 3. And now I take the square root of the things that I know how to take the square root of, like the square root of 16. I know the square root of 16 is a 4, so it goes to the outside. It's a change number on the outside. The 3 is still trapped, so it becomes 4 root 3. All right? So I break it down into perfect squares, and I take the square root of each perfect square. All right, same thing with the next one. This is a 98, which I can break down into a 49 times 2. And now the square root of 49 is going to give me a 7, so I put a 7 on the outside. The 2 is still trapped, so I get 7 root 2. And that's it. As soon as we start to throw some variables in here, the numbers out front don't change. I still do the same thing with those. So the 27 I'm going to break down into 9 times 3. With something like the variables, there's 2 ways you can approach this. When I take the square root of a variable, I'm going to divide it by 2. Remember, I take the exponents, I divide by the root. So I need exponents that are divisible by 2. So I can think of it this way as an x to the 4th times x. That's the same thing as x to the 5th. Y to the 10th is already a perfect square because it's got an exponent that's divisible by 2. And now take the square root of each of these things. The square root of 9 gives me a 3. The square root of x to the 4th gives me an x squared. The square root of y to the 10th gives me a y to the 5th. Again, I'm just dividing each of the exponents. And then under my square root, I still have a 3 and an x that are trapped underneath here. Okay. The other way to approach that, and the other way to think about the variables, I'm going to do the same thing I did with the numbers. That part doesn't change, so I would still do the square root of 9 times 3. The other way to do this is just to leave the variables the way they are no matter what. And then as I take the square root of these things, like when I do the square root of 9, that gives me a 3. But now when I do the square root of x to the 5th, I basically divide the 5 by 2. And when you think of 5 being divided by 2, 2 goes into 5 2 times, so I put an x squared on the outside, with a remainder of 1, so I put an x to the 1st left on the inside. Okay, so I think of it in terms of division, but I think in terms of how many times this go in with how many left over. So 5 divided by 2 is 2 with a remainder of 1, so I have an x squared on the outside next to the first on the inside. And then I get to do the same thing with this guy. When I divide 10 by 2, it gives me a 5 with a remainder of 0, so I have no y values left under the square root. And then, of course, that 3 that was in there is still trapped. So I get the same answer either way. So whichever approach works best for you, that's the one you want to go with. All right. If I take a look at the next one, again, when I do this one, I've got the 72, which I can break down into 36 times 2. I'll do the other approach this time, so it's x to the 11th, y to the 2nd, and z to the 6th. And now when I look at this thing, I say, okay, the square root of 36 is a 6. When I try to take the square root of 11, basically I do 11 divided by 2, and 2 goes in there 5 times, so I do an x to the 5th. With 1 left over, so there's going to be a 1x left underneath the radical symbol. I do the same thing with each of these. Here that divides and gives me a y with none left over. Here the z to the 6th I divide and I get a z to the 3rd with 0 left over. So the only thing else that's left under the radical is that 2. All right, and that's the other approach for doing these. Okay. If I look at the next one's got a cube root here. So in terms of a cube root, I'm looking for perfect cubes this time. So for the 54, I'm going to break that down into 27 times 2. This one I'll do the original way. I need exponents this time that are divisible by 3, so I'm going to break that x to the 11th down into x to the 9th times x squared. The y to the 15th is already divisible by 3, so I'm going to leave it the way it is. And the z to the 6th is already divisible by 3, so I'm going to leave that the way it is as well. Okay. The cube root of 27 is a 3. The cube root of x to the 9th is x to the 3rd. I'm dividing the exponents. The cube root of y to the 15th is y to the 5th. Once again, I'm dividing the exponents. And then the cube root of z to the 6th is z to the 2nd because I'm dividing the exponents. And then under my cube root, I still have the 2 and the x squared left over. Okay? If I take a look at the next one, this one I'm graphing a parabola or a quadratic here, so I know it's going to look like a parabola. And the first thing I need is the vertex. And remember, when we're in standard form, to find the x value of the vertex, I do the opposite of b over 2a. So this one I do the opposite of b. That gives me a -1 over 2 times a, which in this case is the 1/2. And now I just have to simplify that a little bit. So in the numerator, I've got the -1. In the denominator, 2 times 1/2 is a 1. So now I have -1 divided by 1, which is -1. That's just the x value for my vertex. That basically gives me half of my vertex. To find the other half of the vertex, I just have to plug that -1 into the equation. So I've got 1/2 times a -1 squared plus a -1 minus 4. Now I just have to simplify. That gives me a 1/2 times 1. So that gives me a 1/2 minus 1 minus 4. And when this is all said and done, this is going to give me like a -1/2 minus 4. I'm going to leave it as a mixed number, it's -4.5 here. And the reason I leave it as a mixed number, typically I'm not a big fan of mixed numbers, but because I'm going to be graphing this thing, graphing mixed numbers is a lot easier than graphing improper fractions, okay? And now from here, the axis of symmetry is always x equals the x value from the vertex, so it's x equals a -1. The y-intercept, I would just plug a 0 in for x, and if I were to plug a 0 in here for these x's, I'd find out that y equals a -4, so when I plug the 0 in, I got a -4 out. And then the x-intercept is when I plug a 0 in for y. So if I plug a 0 in for y over here, I'm going to have to take this thing off to the side and solve it. If I plug the 0 in for y, I'd end up with this. The 1/2 x squared plus x minus 4 equals 0. Well, I'm just solving this quadratic. I can either use my quadratic formula or completing the square, or if at all possible, I want to factor this thing. And right away, that 1/2 is going to cause me some issues, so I'm going to multiply each side by 2 to get rid of the 1/2. So what it leaves me with then is x squared plus 2x minus 8 equals 0. And I want to solve this. Always check factoring first, so I build a bridge. That gives me a -8. Two numbers that multiply together to give me a -8, but add together to give me a +2 or a +4 and a -2. So then this thing's going to factor into an x plus 4 and an x minus 2. Now I can set each factor equal to 0. The x plus 4 equals 0. This thing went a little nuts on me. And the x minus 2 equals 0. And then I solve each. So when I solve each of these, I find out that x equals a -4 and x equals a +2. And then from here, I can just rewrite these as ordered pairs, and then that'll help me graph this thing as I go to plot these, all right? So now that I have all this stuff, I'm just going to start to plot all these. So I've got the -1, -4.5 is about here. The axis of symmetry I can graph as a dotted line. The y-intercept at -4, I can reflect that using the axis of symmetry, so it gives me 2 points actually. And then the x-intercepts, I've got one at -4, which is back here, and one at +2, which is up here. And we can kind of see this parabola taking shape, and so now I can graph this thing, and it looks like this. All right? And that's all there is to it. So again, the reason we're plotting, getting all this information is just because it makes our graph a little bit nicer and a little bit more accurate as we go to graph this thing, okay? If we look at the next one, instead of being in standard form, it's in vertex form. So remember, when things are in vertex form, it's this form, y equals a times x minus h squared plus k. So essentially, the vertex here is given to us. As we look at this thing, I take the opposite of this guy, and I take this guy just as it is. So my vertex is going to be -2, 4. And that's the nice thing about vertex form, is the vertex is essentially given. Axis symmetry is still going to be x equals the x value from the vertex. The y-intercept this time is a little bit tricky, because the y-intercept, you plug a 0 in for x, and when you do that on this one, we actually have to simplify this a little bit and combine some like terms and that kind of stuff, so I actually have to plug this 0 in. That gives me a 2 in the parentheses, squared is going to be a 4. So I end up with y equals a -8 plus 4, so I find out that y equals a -4. So that's my y-intercept. Again, I plugged a 0 in for x, so when we think about this as an ordered pair, plug the 0 in for x, and I got a -4 out for y. And now for the x-intercepts, I have to plug a 0 in for, let me section some of this off a little bit. For the x-intercepts, I have to plug a 0 in for y. If I plug a 0 in for y, I end up with -2 times x plus 2 squared plus 4 equals 0. All right? And now from here, if I want to solve this thing, I'm going to use my square root to solve this thing, because it's kind of in that format. And this is basically what it comes down to when we're solving by completing the square. I subtract the 4 from each side. That's going to give me the -2 times the x plus 2 squared equals a -4. And now I still have to get the square root by itself, so I'm going to divide each side by the -2. So I end up with the x plus 2 squared equals a +2. And now from here, I'm going to take the square root of each side. When I do that, I end up with the x plus 2, because the root and the exponent cancel each other out. Over here, I get plus or minus the square root of 2, because remember, anytime we take the square root of each side, we have to do plus or minus. And now I subtract the 2 from each side, so I get these two kind of radical answers, -2, let me try that again, the -2 plus or minus the square root of 2. All right, so those are my two x-intercepts, and I can leave them that way, the -2 plus or minus the square root of 2. That's what I'll put on the line here. And in that format, it really doesn't help me in terms of graphing. So if I were to plug each of these into the calculator, it's actually going to give me two separate ordered pairs. And I could plug it in just to give me a little bit extra in order to deal with this graph. So if I plug each of these in, when I do the -2 plus the square root of 2, I get a negative about 0.6. And then when I do the -2 minus the square root of 2, looks like it gives me somewhere around a -3.4. So I get these two more values that I can graph here. And let's just check it on the graph as I plot all this stuff. So we've got -2, 4, which is up here somewhere. I've got the axis of symmetry, which I graph as a dotted line. I've got the y-intercept at -4, which is down here. I can reflect that point, which is over here. And now if I check those x-intercepts, somewhere around a -0.6 would be around here. Somewhere around a -3.4 would be around here. And we can see that those points look like they're about reflections of one another, and they look like they make sense in terms of this parabola. So now I just go ahead and graph the parabola as best I can. And that's it. Okay?